Filip Aronshtein.
I'm Peter Weiss.
This is our circuit. So we have a low pass filter over here on this side. We have a high pass filter over here. And when they're connected, they become a band pass filter. So we have our input signal here going through a 3.9 kilo ohm resistor to the inverting input of this op amp. And across the inverting input and the output of that op amp, we have a 1 nanofarad capacitor and a 8.2 kilo ohm resistor
In parallel.
Right? And then we scope at that output point right there, where the top of the green point is. We scope across there and ground to see the output of the
low pass filter.
For the low pass. And then for the high pass, we have the other end of the green. That's sort of where our input comes in from, going into this capacitor, this 1 microfarad capacitor, and this other 8.2 kilo ohm resistor. Those two are in series, and then across the inverting input and the output, we have another capacitor of 22 kilo ohms. And then to scope that, we would just go from the green point over here to the output point right around here.
We would just scope the output for the high pass filter. And then we connect the two filters to form a band pass filter.
Yeah. We would measure across.
With the small green wire, that's what's connecting them. So when we are measuring them separately, we take out the green wire, but when we measure them together, we include the green wire to connect them.
Yeah.
Okay, so now we have our data. So this is for the low pass filter. You see there's a gain of about 6.5 here in the pass band, and then we drop off for high frequencies because it only passes low frequencies, and the 3 decibel cutoff frequency is where this crosses around
It's about
where this crosses around 3.5 decibels, because 3.5 decibels is 3 less than 6.5. It's about 17, maybe 18 kilohertz here. A little to the right of this data point is where it crosses 3.5 decibels. This is the high pass filter, so again it only passes high frequencies. And so this is the pass band. The gain for the pass band is about 8.5 or 8.6. And the 3 decibel cutoff frequency would be where this crosses 5.6 or about 5.5, which is almost exactly this data point, which is at about 20 hertz. So the 3 decibel cutoff frequency for the high pass is around 20 hertz. And now the band pass, the gain is higher because it gains the product of the gain for those other two. So in decibels, the product of 5.5 and 3.5 is 6.5 and 8.5. The product of 6.5 and 8.5 is about 15. So we have 15 decibels here in the 3 decibel cutoff frequency, where it crosses around 3 less than 15, which is 12. So it crosses 12, and again, the same frequency as the low pass, or the high pass, which is what we expected, around 20 hertz here, and it crosses 12 here at around the same frequency as the low pass, which is about 17 kilohertz here. So we have 20 hertz and 17 kilohertz for the 3 decibel cutoff frequencies, with a gain of about 15 for the band pass filter.